Hi, everyone. Thanks for being here. Yes, we're going to talk about intelligent data retrieval for AI applications specifically. I tend to walk around a lot, but I'm supposed to be here, so I'll be very fidgety, and I'm sorry about that. But before we get started on the topic, I want to tell you a little bit about why I care about this topic so much. And it's primarily because I've spent a lot of time, grad school onwards, building, shipping, selling, commercializing, popularizing some of the more seminal distributed data systems. And what I've learned over that time is that data tends to be the hardest part of building an application, any application, not just AI application, right? Managing the data, getting it to the right place, storing it and also retrieving it and using it at the right time is always the most complex part of building any application. And with AI, I think it's become even more extreme, that sort of need, as well as the management and flow of data. So to me, I am super passionate about how data is used in any technology, new or existing. And that's what sort of brought me to this sort of data and AI space. So, we're all here because AI is changing the world and changing the way people work. But I feel that we're still just scratching the surface, right? Are we really solving the hard problems with AI? Are we really solving the complex decision making and automating all of those types of things with AI? Maybe not. So let me talk to you about a customer support example that actually got me to thinking about these gaps between data and AI. So imagine you've made a purchase online after a long time, you bought a gift for someone. And after a lot of hemming and hawing, you're finally making the purchase, you're super excited about it, and you go through the buyer workflow, and then after you've submitted your credit card or whatever, the page hangs. So now you don't know whether the order went through or not, right? So maybe you could make another order, but then the refund policy and the cancellation policy isn't such that you could just return stuff. So you may end up with 2 orders, right? But you don't know if your credit card was charged or not, right? So then you really need to know what happened to your order right then, right? That's the key. You really need to know about that order right then. But you don't. So what do we all have to do? We have to first call customer support, which means talk to a chatbot, right? And we all love chatbots. We are at an AI, conversational AI is great. We're at an AI conference. But when we want to talk to this chatbot, the chatbot's like, hey, how can I help you? Who are you, right? And what's your order number? So I can tell you who I am. I can tell you, whatever, account ID and all that stuff, but I don't have the order number. That's why I'm there. So it can't help me. So we're familiar with this workflow, right? It's going to connect me to an agent. Now, the agent is going to be like, oh, I see that your order went through, right? And they're like, I don't know why you didn't get an email. Maybe a server-side crash happened, maybe the workflow got interrupted, I don't know. But I know that the order went through, and I know that the email wasn't sent, because again, it's in your CRM system that the email did not go through. So why don't I just manually push the email, right? And so now I have order confirmation, order number, I'm fine. But that took me, and this is actually what happened to me, which is where the sort of thoughts around Snow Leopard came to me, but that took an hour because the agent wasn't free, wasn't available. So I sat there on the phone for an hour for them to look up 2 different systems just to push a button. And that's frustrating because all the data is there, right? There is even automation around that data, but in this particular case, it's not connected to, that chatbot is not connected to the live data, so therefore doesn't know what happened in real time, right? No amount of ETLing is going to give you that answer, right? Now, that's not the only isolated case of this type of issue where you need a human in the loop, right? There's lots of business use cases that we all actually go through ourselves, right? Like, so in the first use case, I am the human in the loop, right? If I want to know the answer to that question, I have to go to DoorDash or whichever order delivery system. I have to look at the orders. I have to look at like the order details, and then I have to do a join in my head, right? But all the data is still available, right? Sometimes it's through APIs, sometimes it's in the database, sometimes it's in like a SQL system, a non-SQL system. Like, but the point is the data is there. It's just not connected to, in real time, live to the AI, right? The other one, this is again one of those things, right? If it starts raining today, Walgreens is gonna run out of umbrellas, let's say, and the store manager is like, hey, when are my umbrellas gonna be delivered, right? Am I gonna get an umbrella delivered today? And the AI in that case actually has to connect you to a human agent, because the human agent has to look up maybe the real-time inventory delivery system, maybe look at the live fleet management system to see where the umbrellas are being shipped and can they divert it or not. So again, the data is there, it's just not connected to the thing that can answer that question, right? So there is a human in the loop requirement, which is frustrating, and this is the kind of stuff where you can't actually truly realize full business value, full automation for a lot of things because of this like gap situation, right? So, so in my opinion, right, like we're not realizing the full potential of AI because there is a chasm between the live business data and the AI, whatever the AI means here, right? It could be LLMs, it could be machine learning, like you custom-built models, it could be a huge, complex expert system, right? The point is the AI is not connected, especially for GenAI apps, actually, AI is not connected to the data where it is at the right time to get the right information, right? And of course, there's a lot of work happening in this space, right? There's a lot of solutions to do this. So before you throw stones at me, like, let's walk through what are the techniques that are used to, sorry, it's flashing, right? Okay, thank you. Why is it, where are we at with the current techniques for bridging this gap, right? There are techniques out there people are using, and there's a bunch of discussions even today and yesterday around it. So let's get into that, right? Like the first technique, if we go in chronological order of where we started and where we are today, which actually is a very compressed timeline too, but still, like, you know, we started with fine-tuning, which is taking an existing LLM and changing its weights and hyperparameters for specific use cases to get better results, right, ultimately. And so, right, like it's useful for all these like very specific and common use cases. As I said, I'm gonna walk around. And it's really sort of where the data is static in nature, right? So the considerations, as I say here, are like, you need a lot of data to train, right? Like, or to even fine tune, right? You need accurate, labeled data, you need the expertise to be able to do it, you need to have compute power in order to run these. Some of these fine-tuning mechanics can be pretty expensive and pretty complicated. And ultimately, after all that, it's really good for like static data sets, right? It's for static use cases or semi-static use cases where data freshness and liveness are not critical to the business use case or to the workflow, right? By the way, I will get to RAG, but like that stuff around fine-tuning like gets even more acute when you're talking about custom building models, right? You need even more expertise and even more data and even more cleaning and prep and even more computational power. So when I say fine-tuning, that same stuff applies to if you're building your own custom LLMs too. So RAG, right? Retrieval Augmented Generation. Lots of talks about this. This has become, over the last year or so, the de facto for how you do GenAI apps, right? So this is the way to connect stuff, right? And basically what you're doing is you're ETLing your data into a vector database and connecting that to the LLM, right? And it's great for like, you know, chatting with your PDFs and, you know, having conversational AI for the kinds of things that I was talking about where the data freshness and staleness are not the most critically needed. But RAG, like, because it's ultimately ETL, it suffers from the inherent issues of ETL plus loss of accuracy, right? So for any of us that have built any system that has any amount of data in motion, ETL especially, ETL is inherently stale, right? Even if you're updating data every like 30 minutes, it's still inherently stale, and it's sort of less performant because it's going through a data pipeline that is complex, brittle. Anytime you need to change anything in that data pipeline, like you have to like do a huge effort, software effort, like to do that. And in a lot of cases, you actually have to build an entire new pipeline or a new workflow because you want to accommodate a different use case or even a slightly modified use case with a slightly different set of data, right? So anytime you add a data source, like you actually have to do a bunch of engineering work to accommodate that data source. So there is like inherent staleness and delay. On top of that, you're sort of losing accuracy because you're taking data and changing the very nature of it by putting it from like a structured or semi-structured or API-based system where it's like defined in a certain way, right, in a deterministic way, and putting it in a fuzzy matching system, right? So you're losing accuracy. And so therefore, it's like not the best of both worlds, right? Like you're basically losing that accurate, well-built data into this fuzzy logic system, which is great, again, for like chatting with PDFs and like, great for multimodal unstructured data. But ultimately, it's not great for when data freshness and accuracy are critical for workflows. So we come to AI agents, which again, there's a talk at this conference around it, right? It's the latest and greatest way of automating intelligence in business systems, right? But ultimately, these are very specialized use cases, right? They are purpose-built with specific goals and rules. Hierarchical agents sound super cool, right? In order to like actuate a bunch of actions using GenAI and LLMs and stuff like that. But in reality, in practicality, actually building these systems is arbitrarily complex, right? Like it's really complex to manage and build and plan these systems. It requires even more specialized talent, which is, as we all know, hard to find. It requires even more training, and it's more expensive to like get the data together, to get these systems in place, train them. And again, they're purpose-built, so they have very specific and narrow applicability. And so if you have that kind of data and compute and expertise and time to build these systems for their purpose-built nature, then that's awesome. But they don't scale, right? They're not scale, and they're certainly not reusable in a scalable way, right? So there is still, in spite of all that, like, also AI agents are new, right? So there's a lot of unknowns around them as well right now, right? So we're all trying to figure them out. But even with that, there is still a gap between live business data and the AI-powered systems accessing them directly, right? Even when it's done, like we talked about, it's done in very narrow and specific ways. So it's not, again, scalable and generically available and applicable even now. And so this is sort of why I started Snow Leopard, right? The aim of Snow Leopard is to simplify AI workflows and like unlock those live business use cases, unlock the true potential of AI in business and critical workflows. And to me, like the technology has to be in service of making things better for people. And I believe we do that with the first step as unlocking sort of live business data and making it accessible to the powerful AI systems that exist, right? And solving that live data problem, I think, is really critical for really automating business use cases. So why are we different, right? Like, I think the way I think about it is that we are building intelligence about the data at Snow Leopard instead of building complex data pipelines and building intelligence around the pipelines, right, and around the workflows. So specifically, we're querying the data from the source at query time and natively instead of doing ETLs and building data pipelines, right? So the data source could be anything. It could be databases, it could be APIs, it could be semi-structured databases, it could even be a vector database, right? The point is that instead of doing a lot of complexity around data in motion, you leave the data where it is. Imagine that, right? Like you leave the data where it is and you fetch the right data with the right freshness. Not every use case needs live, like the freshest data. But when you need it, right? Like, and in that case, like you should just go get it from where it's stored. Instead of changing its nature, just go get it and query it natively, right? If it's a SQL database, use SQL. If it's an API, use the API. If it's a JSON database, use a JSON object. If it's a vector database, use similarity search, right? Like whatever, wherever the data is, it should be fetched when you need it so that you can get the most accurate, the freshest, the livest version of that data, right? That is the difference between what we're doing and what else exists out there, right? And so obviously, to me, but the benefits here are like accuracy increases because you're getting the freshest data and you're querying it natively. It gives you better performance because you're sitting next to the data. You're again fetching it from the data source instead of building a whole complex pipeline to like transfer data from here to there, and then from there to there somewhere else, and then like dump it, and then extract it from that dump, and then put it somewhere else, and then extract it from that dump, right? That's just expensive, complicated, hard to reason, hard to maintain, hard to manage. So this allows us to be, like, for the system to be cheaper, and ultimately, the real thing, the value to me is that it opens up business use cases or decision-making use cases that we just haven't been able to attempt so far, right? So we're pretty early, but we've already been having a bunch of interesting conversations with companies around how they could use this. So if you have questions, we'd love to talk to you. If you have, I'd love to learn more about your use cases. So yeah, please come talk to us. We're here to work together to solve that sort of chasm between live business data and the real potential of AI. Thank you. I think we have time for a couple of questions in case there are any. If people want to take a break, that's also cool. Yeah, please go ahead. Sure, but will it, so first of all, that's sort of what the agentic framework stuff does, right? Yes, and so if you're as I said, if you're building the agentic framework to answer exactly that question, that's great, but it requires building those function calls, right? Like, so we're talking about really low-level APIs in that case, like function calls, in order to build this, right? So can you write a device driver? Yes. But does everybody need to write a device driver to answer the same question or use that device driver to like answer multiple different questions? Not really, right? Like there's a question around you can use functions for that specific use case, but for the use case where it's not actually sort of just one system, it's multiple systems. So in my case, the first question was, sure, the order went through in the order management system, but why did the email not go out? For that, you have to go to a different system that has a different API that you have to look up. Now, maybe you've set up the system to have both those things, right? But it's not necessary that for every question, all the data is going to be connected to your data source. And if you're building that, then that's great, but you have to build it, and you have to train your AI agent to do that kind of question and answer for order management. But now, like, can you use the same pipeline and the same function calling and the same setup to answer questions around inventory management?
Well, those are all good points. My question was more, then I didn't quite understand what it is that your system does differently.
It's not doing function calling, right? It's just connecting, like if an LLM, if a question comes in, based on the question, we can intelligently figure out which of the many, like if you need to go to Salesforce, if you need to go to MySQL, to Postgres, to like Quadrant or whatever, it can go at query time to fetch data from that system. But when the order management system, you have to build exactly the function that you exactly need to go call the exact API in the exact system, right? So you have to know beforehand that you have to connect to, if the order management system is Salesforce, then connect to Salesforce. That's the point. In this case, you don't need to know beforehand. Yeah, please go ahead. Can you, I didn't hear you. Can you repeat that, please?
Are you saying that rather than building your business logic into your ETL and putting that all together, that you can build that business logic further down?
Yeah, so the question is like, do you need to build, instead of building the business logic in the ETL, can you build it downstream, right? I'm actually saying take a step back. Build your business logic in your app. Fetch the data when you need it. So you're not, in fact, you're not building the business logic in the ETL. Because then if you need to change your business logic because, oh, I now have to connect to, I moved from database A to database B. Database B has like a whole different schema going on. So now you have to change your business logic, right? And I'm saying don't. But you can just go build a business logic of what you need and let Snow Leopard fetch the data to accommodate that business logic. Does that make sense? Right. I think we have time for maybe one more question. Yeah, please go ahead.
We've done something similar, seen other things like Denodo. So I'm wondering, what if the source that you want to connect to is a very large source like an SAP, where it's extremely difficult to process all those records? Have y'all had any kind of experience in that area, or do y'all address it?
We don't yet address it, but the the question, to repeat it, is have we addressed anything around large data sources like SAP? And the point there is that I'm not ETLing. Snow Leopard is not ETLing, so it doesn't matter how large the data source is. You have to go fetch 1 record or 10 records or whatever, right? But the point is you're querying the data source natively and at query time, so you're only fetching the data that you need. You don't actually need to ETL it to somewhere, to like a lake or a warehouse or something.
What I'm saying is that when you have some of the large data sources, even if you query exactly when you need it, summarizing and dealing with something that's so large can be a challenge. So that's what I'm talking about. Because you don't have to move it. I was saying Denodo is a product we've used in the past that does virtual data warehousing. So I was wondering if you had something that addressed that challenge of really large data sources so that it's going to take a while to get that answer.
Yeah, so I guess what I'm trying to say is I'm not talking about summarizing it, right? I'm talking about you tell me what data to go fetch, I will go fetch it. It doesn't matter what scale it's at, right? We have solved, like I will claim that we have solved the scale data problem with Spanner, with a lot of like those kinds of things, right? That's actually not as complicated as like which data source to go query for which type of question or which type of decision making. That's the hard part. Sorry, I think we're about out of time, but I'm happy to answer any other questions. I'll be here for a couple of minutes, and I really appreciate everybody being here and talking to us. Thank you.